Hello everyone and welcome back to our channel Biodiversity Conservation. I am Subhalakshmi Rao from Ambika Prasad Research Foundation, India, and today we are going to talk about the importance of measurement in research. So let's start. So in general, measurement is actually the physical measurement of any object that we do using scale or thread. But in research, measurement is not only taking the measurements of any object, but also quantifying the data. Means whatever we have gathered, we have to um, give that into idea, and idea is measured in research. So there are some ways to do this, mainly by um, some scales that are used for measuring, and by assigning numbers or values to some properties of an object, we can measure those. Like we have to say measure the social conformity or intelligence or marital status of a population, then we can assign some numbers to uh, the characters, like say we are assuming unmarried individuals as 1, married as 1 plus 1, and those are some of the assigning numbers that we do to make the research easy. So it is mainly a process of mapping aspects of a domain onto other aspects of a range according to some rule. So that rule is given by us to make our measurement easy. So there are some situations like when the numerical data is coded, and we give them some numbers. Those type of data are measured through nominal data measurement, and sometimes in some situations we cannot do the numbering. So we set up all the inequalities or all the data um, in a way so that we can uh, scale those. So in that case, we call it ordinal data. Like when we are measuring um, the hardness of water or uh, hardness of any compound, then we have some scale. That scale is basically ordinal data scale. Next is when, in addition of setting of inequalities, we also give the differences, means from this to this value, from this to this uh, interval. So that data is referred to as interval data, and the scale used is interval scale there. And next is when we are setting up the uh, inequalities or the differences, and we also give a quotient or any mathematical operation in that area, then the data will be ratio data, and those are mainly used in measurements of length, height, amounts, money amounts, weight, volume. So these are some of the data types. Next is measurement scales. So all those data that we gathered as nominal data, ordinal data, or interval data, or ratio data, those are all measured through some scales. Those are nominal scale, ordinal scale, interval scale, and ratio scale. So in case of nominal scale, we are assigning some number symbols to the events to label them so that we can do the measurement easily. So like we are assigning numbers to the players in the cricket team or football team so that it will be easy to uh, locate or identify them. So nominal scales actually provide us with convenient ways of keeping track of people, objects, and events. So this is one way of measurement, and it is the least powerful level of measurement, nominal scale, and it doesn't show any order or the relationship between the two objects. Next is ordinal scale. It is the lowest level of the ordered scale, and the ordinal scale actually places events in orders, and there is no attempt here to make an interval of the scales. Um, and Here we can measure the ranks of students. So because it is a qualitative analysis, so we can easily measure the ranks of students using ordinal scale. And the next is interval scale. In case of interval scale, the intervals are adjusted in terms of some rule that has been established by the researchers for making the units equal. So interval scales can have a arbitrary zero also, but it is actually not possible to determine for them what may be called as absolute zero or the unique origin. And the main limitation of this scale is that lack of true zero. So it doesn't have the capacity to measure the complete absence of a characteristic. So that is the main difference and a disadvantage. But it is a more powerful measurement tool than other scales. And next is ratio scale. The ratio scale have absolute zero measurement, and the term absolute zero is not as precise as it was labeled and believed to be. We can actually conceive an absolute zero and go through the experiment using that absolute 0 point. So like when we are measuring temperature, we arbitrarily take absolute zero of temperature theoretically so that we can go through the experiment easily. And the ratio scale actually represents the actual amounts of variables, and it also measures physical dimensions like weight, height, distance, etc. Next is sources of error in measurement. So the measurements should be precise, and our main objective should be to avoid any error so that we can get a accurate result. So what type of errors we should avoid? Mainly, there are some sources through which we get errors most of the time. Like there are four types of sources where we get mainly errors: respondent, situation, measurer, and instrument. So respondent, here the error may be due to the false collection of data. Means if we are asking someone about the data that is required in the research, and the person whom we are asking is not responding to us um, because of some of the factors, like they don't want to answer because they are afraid of giving away all the knowledge, or they may have little knowledge. So these are some of the factors that limit the ability of the respondent to respond accurately. So this may cause into error. Next is situation. So there are some situations that may not help us to get the correct measurement. So we have to avoid um, such a situation, mainly like when we are causing interview with the respondent, we have to take care of the situation in such a way that they are not fulfilled with anxiety, or they are not bored, so that they can answer us properly. Next is measurer. So who is the interviewer, or or someone doing the experiments? They have to ask questions or do the experiment in such a way that it will not only help the respondent to ease into the situation so that they can give us the data easily, or in the experiment, the experimental researcher have to take into account all the situations that may hamper the error, and design the research in such a way that he or she can avoid maximum error. Next is instrument. So error may arise because of default or defective instrument. So we have to take care of the requirements in the research beforehand, so that we can avoid any type of instrumental error. There are also errors in sampling that may also give us error while instrumentation. Next is test for sound measurement. So how can we get a good measurement? So there are some tests like tests of validity, tests of reliability, tests of practicability. So the test for validity mainly indicates the degree to which an instrument measures what is supposed to be measured, and validity can be also thought of as utility. That means the test measures what we actually want to measure. Next is test of reliability. So a measuring instrument is reliable if it provides us consistently good and accurate results. So a scale is said to be valid and reliable when, sorry, they are said to be reliable when they are valid. So there are actually um, two ways in which we can improve the reliability. That is by standardizing the conditions under which we are conducting the experiment or measurement. Next is by carefully designing the directions for measurement with no variation from group to group, and that can be done by the trained people. So we have to take into account their suggestions. Next is test for practicability. It is the test where we measure the value by taking into account the measuring instrument. So the measuring instrument has to be judged in terms of economy, convenience, and interpretability. So these are some of the conditions that are required to get good measurement. Now, next is what are the techniques of developing the measurement tools? So, as we know, for research or for any other purpose, we require measurement tools. So, what are the techniques to develop some good measurement tools? Like, first step is concept development. Second step is specification of concept dimensions. Next is selection of indicators, and last one is formation of index. So in the first and foremost step, we have concept development, which means that the researcher should arrive at an understanding of the major concepts that are required in the study. So after the researcher gets all the data about his concept on his study, then they have to specify the dimensions of the concepts that he have developed in the first stage, like by adapting more or less some empirical correlation or intuitive approach. And next, after the dimensions of a concept have been specified, the researcher have to develop indicators for measuring each concept element. Indicators are actually some specific questions or scales or devices that are required while measuring. The last step is of combining the various indicators into an index or formation of an index. So when we have several dimensions of a concept or different measurements of a dimension, we have to combine them into a single index. So this is all from me today. Thanks for watching.